So welcome everybody. My name is Christoph Reller. I'm with PDF Tools and I'm going to tell you something about PDF optimization. First, a few words about our company. We are in the market since 1994 and since 2002, known as PDF Tools. We are co-founder of the PDF Association and member of the ICO. We have server-based PDF software for all common platforms with an emphasis on high performance, high volume and high quality software. Our customers are OEM partners, integrators, IT departments. We have more than 4,000 customers in over 70 countries. So much about advertising our company. Now let's go for PDF optimization and PDF-A optimization. There is not so much about PDF-A in this talk, but I will try to highlight a little bit along the way. So, I have partitioned this talk into two parts. The first part being a rather introductory part where I define what I mean by optimization and I explain areas of optimization, application areas. I talk a little bit about the internal architecture of an optimizer. I talk about PDF ingredients with respect to optimization, and I finally tell you something about different classes or different regimes of optimization. And then I go for the second part, which is the more technical part, where I highlight different features of optimizations, different kinds of optimizations that one can envisage with respect to PDF, concern with PDF objects, fonts, removal of parts of PDFs, images, MRC, which is mixed raster content optimization, and I'll conclude with a small section on special purpose optimization. So, optimization, why would I want to change my PDF? I have a PDF, it's a perfectly valid PDF. Where comes the need from to change anything in that PDF? From my perspective, I have found two very different reasons or two very different views on that. The first one I would term rather historical, file format, historic reason. PDF is easy to write. There are tens of thousands of PDF creator softwares around the world, and you can even write it in your text editor if you really want to. PDF is made with this perspective in mind. It should be, to a certain extent, easy to write. It is not so easy to read or interpret. There are not so many PDF processors or PDF readers or PDF viewers as there are PDF creating softwares. And this is one of the reasons, because this creates a situation in which I can have many ways of creating the same pages, visually the same pages. But internally the PDF can be constructed substantially differently. Now, if I come from a completely different angle at this question, optimization, why? We may turn up with a bunch of PDFs or even really many PDFs that we want to apply to some application, be that archival, printing, sending via email, signing, splitting, merging, converting, whatever. And due to the nature how this PDF is structured, I cannot apply them in this application. So, one possible way to get out is to optimize it in a certain way, such that after the optimization, these optimized PDFs are applicable in the required applications. So if you look at the words that are now on the screen, it's more or less PDF, of course, and then it's optimizing application. And my definition of optimization is always with respect to some application. There is no such thing as a general optimization for all applications. It always depends on the application, and I will try to highlight applications alongside the talk. So, speaking of applications, these are the main application areas that I am aware of. There must be more, of course. Number one is file size reduction. Everybody wants to have their files as small as possible, and of course, this is not. It is not possible to reduce file size arbitrarily. I don't have to tell you that to you. Other important application areas are printing. You don't want your printer to produce hiccups if you print your PDF. Archiving, of course, and conversion to PDF-A. Post-processing of scanned documents and other special purpose application areas. And I have to admit that all of these areas include somehow one, or may include the number one, file size reduction. That's why this features a little bit more prominent in this talk. Yeah. Now, even if we have here a complete list, there is a further thing which turns out to be very important or very difficult to solve. What to do with corrupt no, that's actually not here. Sorry. So that's just what I was talking about before. The application determines what you have to do. Yeah? So it's the application. So now I will tell you, I will make a little digression and tell you a little bit about the architecture of an optimizer with a software developer view. I've come up with two possible ways of making an optimizer, and there must be more, of course. I just show you the two. Number A, you load the whole PDF inside an internal data structure, and then basically you can throw away the input PDF, and then you export that again into an output PDF. And while doing so, you do these optimizations. This, of course, has the advantage that you can apply high-level semantics. You have full control over everything. Now, I would like to show you a second option. You have a PDF at the input and a PDF at the output, as above. But you have a processor in between, and you stream the input PDF to the output, meaning that you can read while writing. You can read the input PDF while writing. And thus, memory usage of such an approach can be much more decreased when compared with variant A. Also, in principle, this can be much faster, and the documents to be processed with such an architecture can be really huge. The skeptics may ask, is this less flexible than A? And just to highlight this, usually you have several phases. In the first phase, the entire PDF is read through without writing anything. It's just analyzed to build this internal data structure. And then in the second phase, the actual output PDF is written. So, what does make my PDF large? I think everybody of you knows a little bit about the internal structure of PDF, so I don't have to tell you that. There are indirect objects that can have streams attached to them, which contain binary data, and these are used to store images from programs, color profiles, metadata, page content, And of course there are other PDF objects, and there is the xref table. And now if I go back to this question, what makes my PDF large? It can be anything of that, really. It depends so much on the nature of the document. It can be images, or it can be the page content, it can even be the xref table. So it's not possible to just only consider one of those items when optimizing for file size. We have to take care of all of them. Before I now start with the features section, I would like to classify what I'm going to tell afterwards into 4 different classes or regimes of optimization, which the first class I name equivalent transform. By this I mean that if we apply this type of optimization, the resulting PDF behaves exactly the same with respect to a viewer or with respect to a text extractor as the original PDF. Of course, file size can increase or decrease, but we usually take care that it decreases. There, of course, are lossy transformations. If we have too much data or unwanted data, then we will get rid of that and the file size decreases. But interestingly, there are also information adding transformations, which can be very useful, and we will see that. And finally, I have a 4th group, which I term general transformation. It's just too general to be, this is used for features that are too general to be put into one of the 3 above classes. So, and here comes now that what I was trying to talk about before. There's a 4th thing that is maybe very hard to implement, and this is what are we going to do with corrupt PDFs or corrupt parts of PDFs? So much knowledge of our companies is there, and I'm of course not going to tell you everything, but I will touch upon that a little bit. So that was the first part of my talk. Now comes the second part, a little bit more technical part, in which I go through all the possible things that you can do when optimizing a PDF for a certain application. I start with PDF objects. I guess all of you know that inside PDFs you have these indirect objects. They can have streams attached to them, and these indirect objects can be referenced. Now imagine the following situation. You have this PDF on the left. You have 8 times, you have there an indirect object with a large binary stream, and you have 8 references, 1 for each object of this. And all these objects are now exactly the same. I have here the example of a color spaces. You may have 8 pages, and each page in its resources directory uses 1 color space, and all these color spaces are the same and they are referenced once. This is really not necessary. This is redundant information, and we can get rid of that by just keeping 1 on the right, just 1 of those objects, and the others just reference them, the other object. This, of course, is a completely transparent an equivalent transformation, so the PDF does behave exactly the same after that optimization. Even simpler, unused objects, unreferenced indirect objects can simply be dropped. This also will never increase the file size, it will always decrease. Now, how come that such PDFs actually exist? That's again the story with the tens of thousands of creators, plus maybe simple transformations like merging PDFs or splitting PDFs have led to situations like that. So there are many PDFs which have exactly that problem out there. There are more things to be done with objects. Objects can be put in, or some objects can be put in object streams, but this increases the load time of the PDF, so you have to be careful what you want to do there with your PDF. And finally, I have this linearizing feature of a PDF for fast web view. Here the application is that if you serve your PDF over the internet, then the client should be able to, as quickly as possible, show that first page or maybe even more. And PDF has this feature of additional information inside the PDF that allows exactly for this. But the point here is, it is additional information that we have to put into the PDF. So this is an information adding transform, which is very often performed, as we have seen in the talk, in the keynote this morning. And it is information adding, so the file size clearly increases, but it can be very useful. Fonts. This is a terribly complicated subject in PDF. I think everybody who has looked at the PDF reference or the ISO 32000 spec knows that PDF fonts are terribly complicated. Fonts consist not only of, let's say, one object or something like that, it consists of many things. On the one hand, we have font-related objects in the PDF, like font objects, font descriptors, encodings, CMaps, and 2 Unicode tables. And on the other hand, we have the actual font programs, the binary data, TrueType font programs, Type 1 CFF, or OpenType font programs. Now, it becomes very quickly clear that the thing I was talking about before, this optimizing redundant objects, does not work with these complicated structures. So, if we want to optimize fonts, we have to look at both, or let's say at all of those objects. It's not possible to only just look at the font program, for instance. And the complexity basically comes from the many, many ways of mapping a character in a show string to a glyph in a PDF. And also this is one area where PDFs tend to be notoriously corrupt. Maybe because it is so difficult to create correct PDFs with respect to font. So I'm going to show you a little bit, so for those who want to know more details, please contact me afterwards. Font programs can be subset. This means, by this I mean the following: during the analysis phase, all characters in all show strings are collected. And those in the font program that are not used can then be removed from the font program. And of course, encodings and tables in the font program have to be adapted accordingly. There are many caveats that come with this. I'll just go through very quickly a few of them. So if you want to know more details, please come to me afterwards. So fonts used in markup or form field annotations usually should not be subset, because otherwise you will not be able to type an arbitrary text there. And for shared font programs, things turn out a little bit difficult because of this mapping from show string to glyph. That works difficult for, let's say, simple fonts and CID fonts. And we often have corrupted fonts, for instance, wrongly embedded CFF fonts, which work fine, But as soon as you subset them, they don't work fine anymore and you have to correct them. But this step is in itself is an equivalent transform. You don't lose anything. And it can have a very high impact on the file size. Another topic is, or a connected topic to that, is merging font programs. So, two font programs, in principle, can be merged if their font name is the same, if they are used in the same way, meaning that both are, let's say, non-symbolic, both are used in only simple fonts and not CID fonts, and if the actual glyph outlines match perfectly. Of course, there are again many caveats with this, so we have to take care about the encoding in CMAPs with simple fonts, of course, and for CID fonts, encodings must be compatible. And in principle, by the way, just as a little detail, in CID fonts for true type, the CMAP inside the true type font can be discarded. There are many more details here which I don't have the time to show to you. But you're welcome to come to me after the talk. One very obvious thing to do is to convert type 1 fonts to CFF fonts. CFF is the acronym for compact font format and is indeed much more compact than type 1. This cuts the file size of the font program by about a factor of 2. So now I come to the last font-related topic. Why not just remove the font program if it takes so much memory of file size in your PDF? This can, of course, remove files dramatically, and of course you only can do that for the 14 standard fonts described in the ISO 32000. But in general, this is very dangerous. I'll show you an example. So normally, the A umlaut via an encoding, so this is a simple font, via the encoding maps to the glyph name A diaeresis, which in turn maps to that glyph outline. Now, abnormally, and believe me, there are PDFs outside there that use such strange mappings. That this is not something that I invented myself. You maybe have a show string Q, which maps via the encoding to the glyph name ampersand, and then in the end you get the outline of an A umlaut. And if that creator of that PDF wants to make everything even worse, then the to Unicode table maps that ampersand to the correct character, such that on one hand the text is correctly displayed, on the other hand you can extract it correctly, yet you are under no circumstances then allowed to remove the font program, because the page will be completely destroyed. So this is a very dangerous operation. While we are at removing things from PDFs, let's have a look at what else we can remove. Structure information, metadata, annotations. That's a very special thing to remove annotations, but it's asked sometimes, and so thumbnails, web capture info, article thread, page, piece info. Now, we have to be careful. Structured information is used in PDF A1. You don't want to remove that if your intention is to convert to PDF A1 level A, excuse me, or anything level A. Also the metadata, of course, you want to preserve in certain circumstances. And by the way, I've forgotten in the slide before, maybe with this removal of font programs, it's also a removal operation. You never want to do this, of course, if you intend to convert to PDF-A. You want to do the opposite. You want to add missing font programs. So images take up a large part in PDFs. I'll just quickly go over some topics here. Images can be clipped to their visible parts, which in general is a lossy transformation. Sometimes it can be equivalent, depending on the compression. Now, some people want to convert the color of their images from CMYK to RGB, for instance. This will take up less memory, of course, or maybe even convert to gray. And in the printing application area, people want to convert RGB images to CMYK, because this is the native printer language, so printing will potentially be much faster then. Of course, I don't know if you can see that from the back, but the image on the right is a downsampled version from the image on the left. There exist PDFs with images on the same page with very different resolution. So it makes sense in certain applications to reduce those images to a common resolution number. Finally, we have 6 compression formats in PDF of which we can take advantage. Some images compress better in one than in another. And also we may want to remove what is called alternate images, but not for printing applications usually. So now we move to the second last topic, mixed raster content optimization, which is very interesting, and I would like to tell you this with the help of an example. Let's say I have this scanned document here. It is scanned very cleanly, I have to admit, but it serves the purpose of showing what I want to show. And you ask yourself, how do I compress this in an optimal way, in the best way? We soon turn up with the idea of not using just one compression algorithm, but of partitioning the image into several features, let's say. We have a background with a color, we have text with a black color, we have colored text with different colors, we have graphical elements like, let's say, the blue here versus the white next to it, and we have photographic images. So there simply cannot be any of those mentioned 6 compression formats which performs well on all of this. So why not split it up? First, we cut out the photographic images. For these we then use the JPEG or JPEG 2000 compression format in a high resolution and decent quality, and we remove them from the total page. So what is left now are graphics and text. Now for these we envisage 2 layers. In principle it can be more, but I explain it with 2 layers. A background layer and a foreground layer, and for each pixel that remains now, I decide, do I want this pixel to go into the background layer or into the foreground layer? And let's say the background is something like the paper background on which this was printed. So in our example, this would be the white thing, and the foreground layer would be the darker stuff like the text and so on. So we make a mask now, so this, what you here see is only the mask, which tells you for each pixel, does it go into the background layer or does it go into the foreground layer? All the black pixels now go into the foreground layer, all the white pixels into the background layer. Now that layers themselves but just contain the colors that should be displayed at that specific pixel. So here the algorithm decides, of course, to use the white background here, and strangely here a little bit of blue. And the foreground, this is all that should be displayed on top of that background, is usually the text color, which is black. Also the colored text, which here for the title would be red, and some blue bits are there. And here we also have this graphic element. Now, if we want to compose now the original image, we proceed as follows. We first put the background, and then on top of the background we put that foreground, but we let every pixel that was assigned to the background, we let it be transparent in the foreground, such that you see the background. And on top of that, we place these two photographic images, and we're done. So this is this can have a very well performance with respect to file size. As you see there, we have 330 kilobytes. If this is compressed, the whole thing is compressed to JPEG, and only half of that if it is compressed with this MRC. So if I may, I know I'm a little bit over time, but if I may,
you're all fine, you're all fine.
I would like to show you two very special purpose optimization scenarios. One is maybe a rather common one, annotation flattening. And bear in mind that in PDF annotations are both, it is markup annotations and form fields. So both go into this. There are scenarios in which you want these form fields to become uneditable, non-interactive, and annotations should be just flattened onto the page. Now the problem there is that for many documents, a thing called appearance must be generated for an annotation because it lacks either this appearance or because of other reasons. Now this in itself may not seem to be so much of a problem. The actual problem is that the ISO 32000 standard does not tell you how to do that. It is not part of the standard. It is not part of any specification. We only have the Adobe Viewer, which does something, and it's basically a reverse engineering task to do that. Now the second scenario which I would like to show you is the following. Assume that we have here a company logo with corporate design colors. Somebody puts that into a Word file. This is converted into PDF, then it is rastered into an image, into a TIFF, then out of the TIFF the JPEG is extracted and put again into a Word, and this again is converted to PDF, and finally somebody decides this must go to an archive, let's convert it to PDF-A. And this is not something that I have invented. There are workflows that turn out to be contrived like this. Now, it's not very surprising that in the end, the color of the logo are not the same as in the beginning. But for corporate designs, it may be important that the colors be preserved for various reasons. So, a very special type of optimization is to do a color correction, in this case just prior to converting to PDF-A, and this color correction just goes through the whole PDF, through all the contents, all the images, and compares the colors with their corporate colors, and if they're close enough, then colors are matched to their true values, or are corrected to their true values. So, I have not covered several topics now which would be very important First and foremost, there is page content optimization, which can have a really significant impact. And then I did not talk too much about PDFA compliance or compliance preservation or removal. And there are other topics like OCR or encryption, which I did not talk about. So what can you take home from this? It's basically this inequality. A PDF is not a PDF, even though it might look exactly the same, or the text extraction might return exactly the same internally. It can be structured completely different. And that ends my talk. Thank you.